Hi guys, today we're going to do, well, exactly as it says in the title, we're going to hide a piece of text in an image. The practice of that is called Steganography, which you can find an entry in the Wikipedia encyclopedia and read about it if you want to. I also prepared an image that we're going to use as the one which is going to contain our hidden message. By prepared, I mean just took any random image found on the internet. Any image will do, so if you're using different image, that's fine. And I would expect this tutorial to be more appealing to, well, essentially to a wider audience because we'll be using practices from both software development and computer science. Um, Software development wise, we're going to use the MVC pattern, then what else? Possibly dependency injection manual one, because we're not going to use any other libraries. And I'm going to use MVC as the hard-coded UI view rather than usual FXML, because some people have been asking whether you can do MVC without having to use FXML. MVC is just a pattern, and the implementation is irrelevant, so which means that you can use anything you want. Computer science, well, we'll do some bit manipulation, so if you don't know what that is, it might possibly be difficult to follow some of the tutorial bits. Excuse the pun. Right, so we're going to create a new package, call it steg, short for steganography, and then we're going to create or rather I'm going to copy that because that's sort of my template. I'm just going to call it steg app. Right, we don't need that anymore. So these are the imports, the typical stuff, tutorial, steg app. And then create content, we're going to use our own view. So we're going to create class. Like I said, I'm going to use hard-coded UI rather than FXML file. Extends pane. View. I'm going to create a controller. I'm calling them they're generic. So if you have a name for your application, you might want to rename this to whatever controller. Right, I'm just going to create some placeholders and then link them together. So get the sort of application infrastructure first rather than trying to do any implementation. Then model. We'll also need some interfaces for, well, we need an encoder, remote interface. So this interface is going to allow us to encode the stuff. So it returns an image by taking one image and then the message to encrypt or encode. Using interfaces is nice because you don't worry about implementation and you can change implementation anytime you want. And we're going to have a decoder which gives us back the message by doing something with an image. Then we'll need some concrete implementations, so basic encoder, which implements encoder. And then basic decoder. And that should do. Right, we no longer need that bit. Okay, so app, what else? So new scene, we're going to create our own view. But because we're creating view manually, we also have to do the wiring manually. So we'll need the controller instance. So this is one of the downsides of doing MVC on your own rather than letting XML take care of that for you. So this is our controller. Controller will need to have some access to the model. Topic controller takes in the model. We also need to have, so the model is going to be essentially a place which gives references to some of the modules that actually do stuff. So encoder, decoder, and then we'll do dependency management here in the constructor. If you were to use an actual tool, you would simply do something like inject and then let the dependency tool take care of the injection for you. Since we're not using any extra libraries, we have to do it manually. That should do, I suppose. We'll do essentially going to copy that. Return encoder, encode, and then image and message. Same with the decoder. And decoder, decode image into our message. So our model is the place where all logic is, but having these sort of as separate modules or separate implementation logic allows us to use whatever encoder, decoder types that we want. So for example, we do one concrete implementation. At some point, eventually you might want to use your own implementation, for example. Then you could easily just pass in concrete implementation here and then not worry about changing the infrastructure. So control will possibly have two methods like on encode. So I'm thinking two buttons on the UI part. Decode. We'll need some UI references, but we don't yet have the UI part. Okay, so new view, which takes in new controller, which takes in a model, which we're going to make slightly different way. Make model, return new model, new basic encoder, new basic decoder, and then pass it in here. That'll do. Let's take care of the rewiring. That isn't needed. We don't need these imports. The view is going to consist of, well, I'm thinking two images side by side. One, the original, the other one is the one where we have a hidden message inside. So if we do this, first need to load the image, which we do by simply supplying the URL. Then we're going to have image view, original view. Get children, all original view. So this will be positioned 0, 0. Then we need to have another image view, modified view. I'm going to move modified view, set translate x by the width. The width of this image is 635. So if you're using a different image, then change these values accordingly. What else? We need to have a button. Actually, we need to have a text field so we can enter our hidden message, or a message to be hidden. Field, enter message. So translate y, the height is 454. So we're going to add the field here. And then finally another, actually now we need a button. Button decode. So translate x 635. So this will essentially end up like a grid 454, and then place that in the UI as well. Right, controller now needs some UI objects. Image view. Again, this is usually done by fxml on injection. Image view, original, modified. And then, what else? I think that's it. But now we need to be able to inject those things. So inject views. Yeah, that should do. Original, image view, modified. Controller, inject views, original view, modified view. Right. Now we need to add some event handlers, set an action on controller on encode. We still don't have access to a text field, so we need to have text field message. Actually, I'm just going to rename this to inject UI and then put everything in one method call. That'll be easier. Field message. Finally, on action here, we do controller on decode, because controller already has access to our modified view, so there is no need to do anything else, I don't think. Right, on encode, we already have access to model, which means image modified model encode original image, yes. And then field message get text. Then modified, I should rename this to modified view. And this is original view. Otherwise, you can get confused. Modified view, set image modified. On decode, string message model decode our image, which comes from modified view. The image. So the decoded message will simply be printed out to the screen, to the terminal. We've done the controller, we've done the view app. Yeah, let's try that. See if this runs. Right, so we have our original image. Somewhere we have down here we have our text field and our button for decoding. Actually, I need to increase the size. So if we set preferred size to something bigger, if the image width is 635, then multiply by 2 to get two images side by side. And then 454 is the width, the height, so something like 500. Yeah, that'll do. And the modified image goes here. Right, now it's down to the low-level implementation of encoder and then decoder, which is going to be slightly tricky if you haven't done any binary or bit manipulation. Right, encode. What do we need? We need to have dimensions of the image. Height. We need to have another copy, which is going to be writable image, because we have to at some point write pixels. New writable image. This is the original one. Get pixel reader width and height. We need to be able to read, so we need a reader. Actually, we need a writer too. What's it called? Pixel writer. So the first thing we need to have is to encode this message into into bits, essentially, because we want to be we want to modify a few bits rather than the whole pixels. This way, you are not really modifying the image from the human eye perspective. It's very difficult to actually trace modifications to the original image. Especially when you don't have the original image. So yeah, there's no bit data structure, or there's no bit primitive. So I'm going to use a billion, which is essentially like a bit. It can be set and it could be unset. Encode text string message. Right. In order to be able to decode, we also need to put some sort of length of the message into the message itself, which means that we need to reserve some space. So data message get bytes. This will return as the actual data. We need to create a billion array bits. So the length, which is going to be an integer, and an integer in Java is 32 bits, which means that we need to reserve at least 32 bits plus data length, which is in bytes. And 1 byte is 8 bits, so we need to multiply that by 8. Now we need to convert length of our message to binary and then essentially to bits. So if we do string binary representation, do string data length, and then while binary length is less than 32, because that might return, I think it returns without deleting, yeah, no extra leading zeros, so we have to add our own zeros. 0 plus binary. Now for 32 bits. We're going to put these into our array by checking if binary character at I equals essentially 1. Because this will return zeros and ones, so we check if it's 1. If it is, then we're setting this particular bit. Now this, we've encoded encode length. Now we're going to encode the message itself. Which is for I to a length of bits. We're going to obtain a byte. Now we have to transform each single byte into 8 bits, which is going to be another loop from 0 to 8, because there are 8 bits. We've already used the 32-bit offset, so we're going to put it here, plus I multiplied by 8. This is the number of bits, and then a particular bit is going to be j, and that is going to equal, we're going to first check by shifting to 7 minus j, because the maximum number is 7, because it's an index. So if I do it like this, 7, 6, 5, so on to 0, this gives us 8 bits, 7 being the most significant bit. We'll do that first. We right shift it, and then we check if it's 1 by doing this. So this will give us the check if it's set or not within a particular byte to convert into a bit. And essentially, we are done. We return bits. So here we've encoded our message. Now we need to alter the least significant bit of each pixel, which we can do using a bit of functional programming, because that is, I think, the easiest way. So I obtain a stream. It's going to be a stream-based API from 0 until bits length, because we don't need to go through each pixel in our image data, only until that value. We're going to map everything into what do we need? We need an index so that we can compute x and y of the image. So to obtain a pixel, we also need a pixel value. So we're going to create a new pair. First is going to be I. Second is going to be reader get argb x and y. I modulus divided by width. I divided by width. This will give us the x, y values of the pixel to read. This will read the actual pixel and then wrap everything into a pair of index and a pixel, which we further map to, this is where we actually encode. So this is going to be new pair again. We're going to continue passing the index, because we'll need to write the index, the pixel index to the copy of the image. The thing that we pass here is going to be the pixel either altered or not, based on, well, altered anyway, because it's going to use bits. It's just we're either setting it to 1 or 0. Pair get key, because this is the x. pair get value, set it to 1. So if the bit is set, then set least significant bit to 1. Else we are going to unset it. So basically 0. And finally we write. We get a pair again. We need x, which is pair get key. Key, if you remember, is the I that we are passing through essentially. Then finally set error to be x, y, and pair get value. So this is the value that we modified as pixel. We first got it as a pixel, then we modified it, and then now we're writing it back, but not to the original image, to the copy of the image. And then we return the copy. Let's see if that works. So if we run that, what type setting? Hello world. Right, so we have an image which is similar. In fact, it's very difficult to see the differences, but ideally should contain the text, which is hello world. But since we haven't got the implementation of decoder, there's no way to check. Decode, something similar. We'll need most of these things, I think. I'm just going to copy this. We'll need width and height. We don't need copy anymore. We need the reader. I'm going to go the easy way and then just read all of the image, all of the bits of the image. Because if you remember here, we encoded the length of the message and then the message itself, and then we kind of shortened the sequence. You could read the image, the message length, and then do that up to that value. But to simplify it a bit, we're going to use the whole image instead. Read, we don't need that anymore. And here we essentially set bits. So we will need our Boolean array back. Width multiplied by height. As you can see, we're reading the whole image in. Bits, well, first we need to convert to binary, and then read least significant bit that we set using this. So we're essentially reading the least significant bit, and then we want to know if it's 1 or 0. Integer to binary string pair get value. Bits pair get key. Key is the index, and it's going to be an index to this array as well, because exactly the same size. And then we set it target binary length -1, because we want the last bit, whether that equals to 1. Don't need that. So we've obtained our bits. Now we need to read length of the message in order to be able to read the message itself. So I'm going to create another variable length. We know the length is going to be 32 bits because we ourselves encoded it as 32 bits. And if you remember, an integer is 32 bits in Java. So for I, 32, if bits I, so this is essentially checking if the bit at that position is true. is 1. Then length addition. We now need to left shift 1 by 31, because exactly the same as we did here. It starts from 7 for a single byte, but an integer, it will start from 31 to give us 32 bits. So it's 31 minus I. This will give us the value to shift it by, and then this will give us the actual shift. And that will be added to the length. At this point, we have decoded the length. So we now know what size array to create for our byte data, which is going to be length. And we're just going to populate this data. Then we need to obtain, again, inner loop 8 bits. So we're going to read 8 bits encoded or decoded into a single byte, because 1 byte is 8 bits. And then at the end, we're going to have a byte array of data filled with the message. So data I, essentially, is actually, we're going to shift that by 1, 7, because it's a byte. So that was the integer, that was byte, minus j. And we have to check if the bit is set. If bits, if you remember, we've already read first 32 bits, so we create the offset again. Then it's I multiplied by 8, because we're reading 8 bits to get a single byte. And then final offset is j, because that will be reading a single bit in that 8-bit range. Yeah, that should do it. Yeah, we're doing left shift to obtain byte data. We've obtained the data itself, and now we're just going to create a string out of data. Let's try this. We no longer need those imports. Hello world creates this image. If we click decode, the hello world text is decoded from this particular image. And as you can see, there's, well, I cannot really identify any differences in the image. So it is very difficult to see if the image has been modified or not. Let's try something longer. Hi, this is a relatively long hidden message. Do this, so it's encoded into an image. I don't think it even changed. Click decode, and this message is decoded from the image. So there you go. We now have a basic steganography tool, which allows us to decode or encode and decode message into an image, and from it, using a very simple algorithm to essentially obtain bits from the message and then use the least significant bits of each pixel in order to decode, in order to encode and then decode from back from it. If you want to know a bit more about the algorithm itself, you can read about it online. Just Google steganography LSB or something like that. This is the sort of typical approach by encoding least significant bits. I also noticed that this returns a RGB, which means that there are 4 bytes. So you could potentially use least significant bit of every single byte in this ARGB pixel value, and then use all 4 channels, alpha, red, green, and blue. The image shouldn't change at all. I don't think it will change because you're only modifying the least significant bit. Apart from that, we also used a bit of functional programming, although this is not purely functional because we're using, for example, here, we're using kind of global state, which we shouldn't use, so therefore this is not purely functional. Also used a little bit of manual dependency injection and the MVC pattern. If you want, you could read on each of those things on their own, and there's probably quite a lot of material online. And I find it quite interesting to mix the patterns together and see what you can get in terms of software development practices and things like that. Alright, this is it for this tutorial. Thanks for watching.